A series of successful flight tests at the Tonopah Test Range in Nevada has confirmed the performance and reliability of the B61-12 nuclear gravity bomb when carried and released by the F-35 aircraft. Conducted by Sandia National Laboratories in conjunction with the National Nuclear Security Administration, the August 19th to 21st tests marked a significant step in evaluating the weapon's behavior during operationally representative missions. The inert test units were supported by aircraft generation from Hill Air Force Base in Utah and followed the NNSA's completion of a multi-year life extension program for the B61-12 in late 2024, extending its service life by at least 2 decades. In this video, Defense Updates analyzes how B61-12 armed F-35 is set to enhance U.S. nuclear deterrence. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The August campaign included the only B61-12 stockpile flight tests of joint test assemblies on an F-35 aircraft, demonstrating the full end-to-end reliability of the aircraft, its crews, and the weapon system. The Sandia website mentions that this test also achieved a technical first: the initial thermal preconditioning of a joint test assembly for carriage on an F-35 before release. This validated the bomb's environmental requirements in a real-world combined environment, further strengthening its qualification for modern mission demands. Stockpile flight testing plays a central role in NNSA Laboratories' annual assessments and supports warfighter readiness. Sandia's Jeffrey Boyd, surveillance lead for the B61-12 and B61-13, stated, "These B61-12 F-35A stockpile flight tests and captive carry flight tests were the capstone accomplishment of a tremendous amount of planning and effort by those who were involved across not only Sandia, but many other agencies. In addition, these B61-12 stockpile flight tests represent the completion of the most B61-12 flight testing surveillance scope in a year to date, and the most in a given year for the foreseeable future." Tonopah Test Range Manager Brian Adkins noted that the test campaign required the team to adjust plans in real time to satisfy both safety and mission objectives. He said, "Expedient coordination by the entire test team resulted in 2 successful days of testing to evaluate 3 test assets. The close collaboration between Sandia's stockpile systems engineers, Tonopah's operational test personnel, and the U.S. Air Force is expected to generate valuable data as analysis continues." The B61-12 has been developed as a forward-deployable tactical and strategic nuclear weapon intended to bolster deterrence for NATO and U.S. allies in Asia. It is a joint program between the U.S. Air Force and the National Nuclear Security Administration, NNSA. Under this partnership, the Air Force procures the Boeing-designed tail kit assembly, which uses a GPS-aided inertial navigation system to guide the bomb with high precision. The tail fins control the weapon's descent, allowing it to maneuver and dive accurately onto its target, while small rockets in the bomb's body provide spin stabilization to further improve accuracy. NNSA develops the bomb's primary assembly and handles the integration of the nuclear warhead into operational units. The B61-12 is not an entirely new weapon. It combines components from several earlier B61 variants, while incorporating updated technologies and improved capabilities. Although the U.S. government has not disclosed the warhead's exact yield, open-source estimates suggest it may reach up to 50 kilotons. For perspective, the Trinity test in 1945 produced about 20 kilotons, while the bombs dropped on Hiroshima and Nagasaki generated approximately 13 to 18 and 20 to 22 kilotons, respectively. The B61-12 includes a dial-a-yield feature, enabling operators to select lower explosive outputs depending on mission requirements. This adaptability allows it to replace multiple older B61 versions that each had fixed yields. Former U.S. Air Force Chief of Staff General Norton Schwartz stated in 2014 that the precision enabled by the B61-12's guidance kit could allow it to destroy hardened underground facilities even without a dedicated bunker-penetrating variant because its accuracy concentrates the blast's effects more effectively. The United States plans to produce roughly 400 B61-12 bombs. The Pentagon launched the F-35 program in 2001 with the goal of creating an affordable next-generation aircraft to replace several aging U.S. platforms, including the F-15, F-16, F/A-18, and the A-10. The jet was intended to become the backbone of American air power and a central component of Allied air forces worldwide. The program produced three variants: the F-35A conventional takeoff and landing model, the F-35B short takeoff and vertical landing version, and the carrier-capable F-35C designed for catapult launches and arrested recoveries. The F-35A entered operational service with the U.S. Air Force in 2016, and this variant would be the one that will be primarily employed for nuke delivery. In March 2024, the F-35A was cleared to carry the B61-12 gravity bomb, making it the first fifth-generation fighter certified for a nuclear mission. Integrating the B61-12 with the F-35 can be viewed as a crucial step, particularly at a time when strategic competition is intensifying and several nations are advancing their own weapons programs. The recent tests underline the F-35's unique status among stealth aircraft. While China's J-20 and Russia's Su-57 incorporate low observable features, neither has been certified for nuclear delivery. The F-35 remains the only fifth-generation platform combining stealth, advanced sensors, and an approved nuclear strike capability. Also, unlike large strategic bombers such as the B-2 Spirit or B-52 Stratofortress, the F-35 can operate from dispersed and relatively small airbases, including short runways, remote airfields, and forward operating locations. This flexibility has major implications for nuclear deterrence and operational survivability. This dispersal significantly complicates an adversary's preemptive strike planning, since they cannot reliably predict where U.S. nuclear-capable aircraft are positioned at any given time. The ability to forward deploy to small bases also reduces response times during crises,